Hello, in this video I'll be explaining a multi-agent system which is built for SDLC. In software development lifecycle, we have various phases like requirements, design, QA, development and deployment. So here we have built agent for each of the phases, and all these agents are driven by an orchestration agent. So there are 6 agents technically. The orchestration agent will have the front end, that is what we are seeing here, the UI, whereas the remaining agents will not have the front end, it will have only the back end, and those agents will be calling the model. The model what we are using here is Claude Sonnet. Here uh, we have governance and guardrails are defined in this project. Governance are nothing but some rules and policies we have to take care, especially when we are using a LLM model like Claude. And guardrails are used for preventing any injection, like prompt injection, and then making sure the code is compliant with respect to the company standards as well as the client standards if anything is existing. And we have an audit trail also. Audit trail will capture the user actions like loggings, what user has uploaded, what is the current status of the um, my progress and all. We'll be going through in detail. So this is the basic UI, and uploads whatever the documents user is uploading as part of the exercise, everything will be tracked here. This is audit trail. Governance, we have built all the governance rules under the claude.md file. Under root, we have one governance, root of the project applies for everything. And under the agent, for each of the agent, we have governance defined under the respective agent claude.md file. And then some system prompts, whatever user is going to enter as part of the prompt, we have taken care of the governance factor. For each agent, we have system prompt, and this is some regulatory kind of things. And then this is a, a file called code owners. It is part of the GitHub. It will, this is like a branch protection policy, like who can approve the pull request and all. And this is role based access control. We have different parties like business analyst, build lead, who can do what has been defined over here. Everything is taken care in the code. Let's start with the exercise. Let's upload a requirement document. I tried with first requirement document. This one will give a prompt injection. Say for example, if I upload this document, so the background, the requirement agent is triggered, which is calling the Claude model that will scan through the PDF document which I attached. Yeah, the scanning is done. The agent has completed the scanning of the document. It has found some one security flag and then one incomplete requirement, 3 ambiguous. We'll go through that. So this is the result. Yeah, here it is requirement 3, security flag. Here the document contains some statement like please ignore previous instructions. This looks like a injection, a prompt injection advising the LLM model to ignore the previous instruction. So that's why we have flagged it. So this analysis, everything, whatever been responded by the agent can be exported to a PDF document as well. If I click it, it will generate a PDF document, which we are not going to do now. So in this case, I'll be rejecting this. At the top, you can see a new run button, which is disabled, as well as retry requirements is also disabled. It will be enabled only if I go for this action like reject. If I'm going to reject this because this is having some prompt injection. Okay, I need to give some comment. uh, Document contains prompt injection. All these things will be logged. Yeah, now this button is enabled, this new run is enabled, so that we can proceed afresh. This button retry requirements is disabled. It will be enabled only if anything failed. Say for example, if agent itself is failed. In that case, if we want to give a retry, we can have to click this retry button. That time it will be enabled. Now agent has not failed. It has flagged actually. I'm going to click the new run. I'm not going to upload the second document which I used in my exercise. I'm going to upload this document, which is this won't have any ambiguity and all. It will be neat and clean. Yeah, going to click the start pipeline. Yeah, see, everything is clear. There are 5 requirements in this document. All 5 are clear. No ambiguous, no incomplete, no security flags. So we are good here now. So after the requirement is done, so these are the requirements from the client. So all the requirements are defined in a uniform pattern like given, when, done. And then we can click this button, approve. This will trigger the next phase, which is design phase. In this phase we will be obtaining the system architecture, the flow diagram using mermaid, and then any database design, and then backend designs, API, like what kind of request, get, post, those kind of requests. Everything will be defined under this phase. You can see over here the previous phase requirement agents requirement analysis has been completed. If you can expand, you will see it what we have seen before. However, I'm going to collapse it. If you want, you can click that button as I said previously. This will take some few minutes, I think 2 to 3 minutes. So the previous agent input will be, sorry, the previous agent output will be the input for this current agent. Likewise, it is a cascading thing. This agent output will be the input for this agent. We are not using LAN chain or LAN graph in this orchestration. We are using the simplest TypeScript uh, tools only for this orchestration. So far, it has been 1 minute and 35 seconds. As I said previously, this is only a prototype, so this can work based upon the design I made. Like a user has to upload a document, whether it's a PDF or Word document, and based upon that, it will keep continuing for the consecutive phases. In the long run, we can make this prototype to be wired up with a, say for example, any tool like Jira or Azure DevOps to create user stories, and it can also work with the GitHub so that it can create the code repository directly into the GitHub, or it can work with the uh, existing code base. It is like we are not going to create anything new in the existing code base. If you wanted to have a minor enhancement, that is also possible. But for that, for everything whatever I told, we need to have those APIs exposed. With the APIs, we can wire up and make it working. The main benefit of having such multi-agent concept is, um, especially towards the requirement and design QA and all, we can save a lot of time. No need to go for a refinement meetings, brainstorming the requirements, analysis and all. The agent will do on behalf of us. And then design also any diagrams like UI wireframes, architectural flow, database design, everything will be done by the agent. Of course, we have to review in each and every phase. Yeah, the design is done, solution design. You can see over here, it has defined 9 API endpoints, 8 DB tables, 21 components, 4 wireframes, user flows, blah blah blah. Here, it has defined the system architecture, backend design, these all the services, APIs, database design. It has chosen Postgres, tables, everything under the system design. We have now the table structure, flow. So all has been defined by the design agent now. This will be the output of design agent will be the input for the QA. So based upon this, the QA agent will prepare the test cases. Okay, I'm going to approve this. See, as soon as you click to approve, the QA test cases agent has started processing. I think this QA test cases agent will take more time compared to design agent. It will go through all the um, output which came from design. It will try to prepare some test cases for wireframes, APIs. And these QA test cases will be used by the development agent, so that once the development agent generates the code base, on top of the code base, the test cases coming from this agent will be executed. We're not using a dedicated testing phase here. We're just using the QA test cases and testing agent here. The outcome of that agent, those test cases will be used as part of the development phase itself. So for development agent, the response from design as well as QA test cases will be used. Both the agents will serve input to the development agent. Yeah, the QA test case agent is done now. It has created 101 test cases, that is on functional, 24 database, 22 UI, 14 security, 16 edge cases. Okay, so these are the test cases. We're not going through each and everything here, and they have a priority, high test cases. These are the steps, and this is the expected result. Likewise, I'm going to approve this. Now development agent has started, which will be using the output of the QA test case plus design agent's output, and this will basically generate the code base. It will give us the code base in a zip format. We'll wait for it. Yeah, development agent is also completed now. This is the zip file which contains many code related files. Looks like it's a React TypeScript using Express, then just framework for testing. Okay. You're not going to download this zip. Yeah, and under this folder, when we extract it, we will have a subfolder called test. Under that, a file called orders.test.ts. This is the test file which will be covering the test cases defined by the previous QA agent. I already downloaded this file in my local. This will look like this. Yeah, this is the one. This is the database structure defined in. This is the source code. This is the test folder, and this is the project file. And then any packages references. We need to set the env file. Okay, right. Now I'm going to approve this.